Hello everyone, we are from Group 1 and we would like to present our presentation that is about correlation and regression that will be discussed in this video based on our PPT that we have created back then, starting from Emy Suryani as the first presenter and me, Maulana, as the last presenter. So enjoy watching the video.
My name is Emy Suryani. I'm from Group 1, and here I will explain about correlation. Correlation is a statistical measure that indicates the extent to which two or more variables fluctuate together. When the fluctuation of one variable reliably predicts a similar fluctuation in the another variable, there's often a tendency to think that means that the change in one causes the change in the other. However, correlation does not imply causation. There may be an unknown factor that influences both variables similarly. Another understanding of correlation shows the strength of a relationship between two variables and is expressed numerically by the correlation coefficient. The correlation coefficient value range between -10 and 10. A perfect positive correlation means that the correlation coefficient is exactly 1. This implies that as one security moves either up or down, the other security moves in lockstep in the same direction. A perfect negative correlation means that the two assets move in opposite direction, while a zero correlation implies no linear relationship at all. Three possible results. First, positive correlation. What is positive correlation? Positive correlation is a relationship between two variables in which both variables move in the tandem, that is, in the same direction. A positive correlation exists when one variable decreases as the other variable decreases, or one variable increases while the other increases. In statistics, a perfect positive correlation is a expression by the correlation coefficient, value +1, 0, while 0 indicates no correlation, and -1, 0 indicates a perfect inverse or negative correlation. Second, negative correlation. Negative correlation is a relationship between two variables in which one variable increases as the other decreases, and vice versa. In the statistic, a perfect negative correlation is expressed by the value -1, 0 indicates no correlation, and +1 indicates a perfect positive correlation. A perfect negative correlation means the relationship that exists between two variables is negative 100% of the time. And the last, zero correlation. A zero correlation suggests that the correlation statistic did not indicate a relationship between the two variables. It is important to note that this does not mean that there is not a relationship at all. It simply means that there is not a linear relationship.
Okay, the next material is diagram. You can see on the slide there are several diagrams, and A. Strong positive correlation between X and Y. The points lie close to a straight line, with Y increasing as X increases. And diagram B is weak because positive correlation between X and Y. The trend shown is that Y increases as X increases, but the points are not close to a straight line. And diagram C, no correlation between X and Y. The points are distributed randomly on the graph. And diagram D is weak because negative correlation between x and y. The trend shown is that y decreases as x increases, but the points do not lie close to a straight line. And the diagram E is strong negative correlation. The points lie close to a straight line, with y decreasing as x increases. And the next material is function. The first is correlation can show whether and how strongly pairs of variables are related. And second one is correlation used to examine the presence of a linear relationship between two variables, providing certain assumption about the data are satisfied. Okay, the next material will be delivered by Yaya.
The next material is types of correlation. Usually in statistics has three types of correlation. These are Pearson correlation, Kendall's rank correlation, and the last Spearman rank correlation. The first type is Pearson correlation. Pearson correlation is widely used in statistics to measure the degree of the relationship between linear related variables. For example, in the stock market, if we want to measure how two commodities are related to each other, Pearson correlation is used to measure the degree of relationship between two commodities. The formulation of Pearson correlation you can see in the slide. And the second type is Kendall's rank correlation. So, Kendall's rank correlation is a non-parametric test that measures the strength of dependence between two variables. The formulation of Kendall's rank correlation you can see in the slide. And the last type is Spearman rank correlation. Spearman rank correlation is a non-parametric test that is used to measure the degree of association between two variables. It was developed by Spearman. Thus, it is called the Spearman correlation. Spearman rank correlation test doesn't assume any assumption about the distribution of the data, and it is the appropriate correlation analysis when the variables are measured on a scale that is at less ordinal. The formulation of Spearman rank correlation you can see in the slide. And the next material will be delivered by Endra Sufanlay.
Okay, I will explain about the definition of regression analysis. Regression analysis is one of the most commonly used statistical technique in the social and behavioral science and physical science, which involves the identification and evaluation of the relationship between a dependent variable and one or more independent variable, which are also called predictor or explanatory variable. In regression analysis, the goal is to get prediction from one variable, give the value of the another variable to accommodate this change in point of view, different terminology and notation in use. The predicted variable is usually denoted by y and the predictor variable by x, with the subscript edited to this with one another. The next material will be delivered by Wahyuningsih. Wahyuningsih, time is yours.
Function of regression. Regression have two functions. First, regression analysis used to explain variability in dependent variables by means of one or more of independent or control variables and to analyze relationship among variables. It to answer the question of how much dependent variable change with change in each of the independent variable and to forecast or predict the value of dependent variable based on the values of the independent variables. The second function of regression is the primary objective of regression is to develop a linear relationship between a response variable and explanatory variables for the purpose of prediction. Assumes that a functional linear relationship exists and alternative approaches are superior.
Now I'll talk about the types of regressions. There are two types of regressions: simple linear regressions and multiple regressions. When there is a single continuous dependent variable and a single independent variable, the analysis is called a simple linear regression analysis. This analysis assumes that there is a linear associations between the two variables. Multiple regressions is to learn more about the relationship between several independent or predictor variables and a dependent or criterion variable. Simple linear regressions. Simple linear regressions is a statistical method that allows us to summarize and study relationship between two continuous variables. In a cost and effect relationship, the independent variable is the cost and the dependent variable is the effect. You can see the formula of simple linear regressions on the slides. Next is multiple regressions. Multiple regression is an extension of simple linear regressions. It is used when we want to know and predict the value of a dependent variable based on the value of two or more independent variables. Multiple regression allows you to determine the overall fit of the model and the relative contribution of each of the predictors. Total variance explained. For example, you might want to know how much of the variation in exam performance can be explained by revision time and lecture attendance as a whole, but also the relative contribution of each independent variable in explaining the variance. The formula of the multiple regressions, you can see it on the slides.
So the next material is hypothesis formulation. Before establishing how to formulate the null and alternative hypotheses, the hypotheses that are made through one or more equalities are called simple hypotheses. The hypotheses are called composite when they are formulated using the operators inequality, greater than, and smaller than. In the context of the regression model, the null hypothesis is always a simple hypothesis. That is to say, in order to formulate a null hypothesis, which shall be called HO, we will always use the operator equality. Each equality implies a restriction on the parameters of the model, and we can see the example as shown in the screen. This is an example of null hypothesis concerning the regression model. And we will also define an alternative hypothesis denoted by H1, which will be our conclusion if the experimental test indicates that HO is false. Although the alternative hypothesis can be simple or composite, in the regression model, we will always take a composite hypothesis as an alternative hypothesis. This hypothesis, which shall be called H1, is formulated using the operator inequality in most cases. As we can see on the screen, are called one-side alternative hypothesis. But in general, a hypothesis is a tentative prediction about the nature of the relationship between two or more variables, and it represents an educated guess about what will happen in an experiment. A research hypothesis is a testable statement derived from the research question. There are two types of hypotheses. The first is null hypothesis. The null hypothesis, or denoted with HO, states that there is no relationship between the two variables being studied, or we can call one variable doesn't affect the other, and it states that results are due to change and are not significant in terms of supporting the idea being investigated. The next type is alternative hypothesis. The alternative hypothesis, or we can denote it as H1 or HA, states that there is a relationship between the two variables being studied, or we can say that one variable has an effect on the other. It states that the results are not due to change and that they are significant in terms of supporting the theory being investigated. Alternative hypothesis, there are two. The first is directional, or one way. It predicts that a specific group or condition will be higher or lower, or have more or less of something, or predicts the specific direction that a correlation will take, positive, negative, and curvilinear. And the second is non-directional, or we can say two-way. It is a significant difference in any direction. And the next is hypothesis testing with Pearson's R. Pearson's R, just like with other tests such as the Z-test or ANOVA, we can conduct hypothesis testing using Pearson's R. There are 7 steps to test the hypothesis using Pearson's R. The first is define null and alternative hypothesis. The second step is state alpha. The third step is calculate the degrees of freedom. The next is state decision rule. The next is calculate test statistic, and then state results, and finally we can state conclusion.
Okay everyone, in this part I would like to explain the use of correlation and regression in certain research article that we have chosen on the Journal of Asia TOEFL, volume 17, number 3, 2020 on autumn. So the title of the research article itself is Using Socratic for Vocabulary Test, TOEFL Learners Acceptance and Perceived Risk of Cheating. And the design of this research is a non-experimental quantitative research. So in this research article or in this study, they use some data analysis including Pearson correlation and multiple regression, and the use of this data analysis for answering certain research questions. So the research questions including how do TOEFL learner acceptance and their perceived risk of cheating correlate with vocabulary learning outcomes and proficiency levels, and the second research question is what predictive roles do learner acceptance and perceived risk of cheating play on TOEFL learner vocabulary learning outcomes. In this section, I would like to explain what the table tells us about. So for the table 3, it tells about learner acceptance of Socratic was positively correlated with vocabulary learning outcomes and proficiency levels, yet the Pearson correlation coefficients are low. In contrast, for perceived risk of cheating was negatively correlated with vocabulary learning outcomes and proficiency levels, and the Pearson correlation coefficients are low too. Yet there was no correlation between learner acceptance and perceived risk of cheating. And now you can see on the table 4 and table 5, it shows the results of multiple regression that they use for analyzing the data. And for the first result of analysis on the table 4, disclose that perceived usefulness and perceived ease of use of Socratic for vocabulary tests made significant predictions for learners' vocabulary outcomes. Then the second results as seen on the table 5 confirms that learner acceptance significantly and positively predict the learner's vocabulary learning outcomes, but when perceived risk of cheating was entered into the model, the results turned into a negative prediction. Okay, this is the end of our video, and we would like to say thanks to everyone who watched our video as the learning material today about correlation and regression, and I hope you all understand, and we have to say sorry if there are any mistake that we have created when we did our presentation, and see you in the next time. Bye bye.